Hi everyone, welcome to today's lecture. Today we are going to discuss linear and non-linear application of operational amplifiers. Operational amplifiers are one of the most important analog building blocks. By changing only external components, a single operational amplifier can perform many different functions. In this lecture, we will understand how operational amplifiers are used in practical circuits. First, we will discuss about the linear and non-linear applications or operational amplifiers. Mainly, the applications of operational amplifiers is divided into two categories. One is the linear applications and another one is non-linear applications. The linear application is one where the output is proportional to the input and it provides a linear relationship between the input and output. There is no distortion within the operating limits. On the other hand, if you take it to the nonlinear application, output is not proportional to input, often works in switching mode, used for decision making and waveform shaping. The next one is linear application of operational amplifiers. The linear application of operational amplifiers are voltage amplifiers. The primary use of an operational amplifier is voltage amplification. The small input voltage differences amplified usually used to amplify a weak signals like audio or sensor outputs. The application includes audio systems, instrumentation circuits, signal conditioning, filters. By combining the resistors and capacitors with op amps, we design active filters like low pass filters, high pass filters and band pass filters, which are used to remove noise and unwanted frequencies. The linear applications of operational amplifiers. The linear application, which includes voltage follower or buffer. A buffer provides a unity gain, high input impedance and low output impedance, used mainly for impedance matching, especially between sensors and loads. The summing amplifiers. The summing amplifiers add multiple input voltages used in audio mixers and signal combination circuits. Linear applications of operational amplifiers again, which includes integrators, differentiators, everything. So if you consider the integrators, the output is proportional to the integral part of the input signal and usually in control systems and signal processing applications. The differentiators. In differentiator, the output depends on rate of change of the inputs used in waveform shapings and edge deduction applications and nonlinear applications. Introduction to nonlinear applications, in which in nonlinear applications operational amplifiers do not maintain proportionality between input and output. They are mainly used for comparison, oscillation, signal limiting and level shifting. Mainly the comparators are used to compare two input voltages. The comparator, which compares the two input voltages, output switches between high and low, used in analog to digital converters and zero crossing detectors. The next one is the regenerative comparators. In regenerative comparators, unlike normal comparators which is an open loop, we are using a feedback, which is a positive feedback. It provides hysteresis, eliminates noise effects. Next one is oscillators. The oscillators is nothing but it provides an output waveform without giving any inputs. So it generates a periodic waveforms used in clocks, function generators and RF circuits. So to conclude today's lectures, we can clearly see that operational amplifiers is an extremely versatile and powerful analog building blocks. By changing only the external components, the same operational amplifier perform a wide range of functions which are broadly classified into linear and nonlinear applications. In linear applications such as voltage amplifiers, filters, buffers, summing amplifiers, integrators and differentiators, the op-amp processes signals without distortion, maintaining a proportional relationship between input and output. In nonlinear applications such as comparators, symmetricals, oscillators, clippers and clampers, the op-amp works as a decision-making or waveform shaping devices, producing digital-like outputs or controlled signals. Because of this flexibility, op-amps are widely used in audio systems, communication circuits, control systems, data converters, VLSI and mixed signal ICs. Understanding this application is fundamental for analog circuit design and will help you to analyze design real world electronic systems effectively. Thank you. Thank you for your patience.